in example 6, we have our ladder. A ladder 10 feet long rests against a wall. So here's my wall. This is my ladder. And there's the ground. Okay, so when a ladder braces against a wall, that's what the picture looks like, and what you'll see from that picture is that it makes a right triangle. So the right triangle formula that you see in your list is going to be the Pythagorean Theorem, c squared equals a squared plus b squared. So the ladder problem will always be that formula. Now then, so let's go back to what it says. A ladder 10 feet long rests against a wall. If the bottom of the ladder, okay, here's the bottom of the ladder, is sliding away from the wall at a certain rate, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? Okay, so let's come up with a formula for this particular scenario. The ground, since that's on a horizontal axis, I'm going to call that x. So my bottom leg of this triangle is x. The blue leg is the wall, so I'm going to call that y. And the ladder is the hypotenuse. The ladder is 10 units long. So that's going to be your formula. Now here's where I came up with that. Your Pythagorean theorem says c squared equals a squared plus b squared. Remember, c is the hypotenuse, which is always opposite the right angle. Now that ladder doesn't change. It's a 10-foot ladder. It doesn't matter how fast it's falling down the wall, it's still going to be 10 foot. So that means that this red part, which is my hypotenuse, that means it's going to be 10. So that's where I got the 10 in the formula. 10 squared equals a squared plus b squared. That's what it looks like. Let's go ahead and simplify it just a minute. X squared plus y squared would equal 100. Okay, now that's what I want to take the derivative of, so that should be really easy to do. This would be 2x dx dt plus 2y dy dt, and the derivative of 100 is 0. So if I come over here to the side, I have an x unknown, I have a dx dt unknown, I have a y unknown, and I have a dy dt unknown. So before we can solve this problem out, we have to put these unknowns in. Now, it tells me that the bottom of the ladder slides away at a rate. Okay, here's the bottom of the ladder right here, and it's sliding away at a rate. Well, that's on the x side. It's a rate on the x side. So that means dx dt is going to be 1. That's where I'm getting that one. The question says, how fast is the top of the ladder falling down? Well, here's the top of the ladder. It doesn't know how fast it's falling, but that's on the y side, and that's a rate. So dy dt, I do not know. That's what I'm looking for. It tells you that the bottom of the ladder is 6 feet from the wall. Notice that doesn't say a rate. It just says, hey, this distance right here is 6. So that means x is going to be 6. But I don't know why. But I have to know why in order to solve the problem. I also know that the y I'm looking for here is not a derivative. So remember, we talked about this in a previous video, that if you're looking for something that's not the derivative, go back to the original function. Your original function here was x squared plus y squared equals 100. So to find y, go back to the original. X is 6. So 6 squared plus y squared has to equal 100. So 36 plus y squared would equal 100. Move your 36 over, so y squared would equal 64. and y would equal plus or minus the square root of 64. I'm only concerned with the positive one, so y would equal 8. Now let's go back into our derivative over here. It says 2 times 6 dx dt plus 2 times y dy dt equals 0. So 12 plus 16 dy dt equals 0. Move the 12 over. 16 dy dt would equal negative 12. Divide both sides by 16, and dy dt would equal negative 12 over 16. That reduces by 4 to negative 3 over 4. You'll notice that that derivative is negative. If that derivative is negative, that means it's falling, and this ladder is certainly falling. Okay, let's go ahead and stop that one, and we'll get one more video in this